Okay, so let's begin with the second lecture for this series. So, where we left it last time was that we showed you the uses of these kinds of analysis, what you can really do with this. This time we're actually going to dive in and we're going to actually, start the analysis. So, first of all, let me help you download all of the things that you need. So the basic thing that you all must do first is that you should go on to environment variables. Just type in environment variables, you'll see this thing. And in the environment variables here, select this path variable, edit it, and make sure you add the Anaconda path here. The folder that you downloaded last time, it'll be in a similar place for you guys, just like it is for me. Make sure that you can, find this path and add it over here so that you're able to use pip install and stuff like that. Okay. Uh, all right. With that done, you should pop onto your command prompt, and here you'll be able to download all of these things that you need for this tutorial. So first of all, I think you need three things here. One second, let me just confirm I was doing this thing. Yeah, all right. So first of all, you'll need the NetworkX, of course. So pip install NetworkX. Oh, sorry. Yeah, that's all you need. I'll push it, but again, the thing is that I already have it, so it's going to say that requirement already satisfied. So nothing's going to come out of it, but for you guys, it's going to install it, all right? Okay, so that's NetworkX. Again, for charting of the sort, what you're going to need is basically Matplotlib because NetworkX basically uses Matplotlib on the backside of it. So really, you should download that. So pip install Matplotlib. That's that. Okay. Again, requirement already satisfied because I already have it. And for C1, this is kind of optional for you guys, but this just gives us, a kind of more better functionality for Matplotlib, like the background here, and there's a couple more things that you can do with Seaborn. We're not really going to be looking into that, but if you do want it, just type in this command, pip install Seaborn, and that's going to download it for you. All right. So that's it for this part. I interrupted, by the way, just so you know. That's no error. I interrupted by myself because I didn't want it to run over all the way. So okay, when you have all of these, now we can really begin with the analysis here. So okay, let's see the basics. Let me create a new one, and let me rename it to, let's see. Okay, that should do. A few basics here. If you're using IPython notebooks for the first time, you should know how this works. Basically, you have a lot of cells here. You can add more cells. These are all dependent on each other. Once you've run this one, let's say x is equal to 4, x is equal to 3, you can actually, check the value of x in this one, right? Okay, so the thing is that if you're using these for the first time, IPython notebook, so what you're gonna have to do is basically learn how the notebooks work. It's a little bit different from the IDEs or from the text editors, but you'll get around it. First things first, let's say you want to add some things, 3 plus 4. How you execute these is by pressing shift and enter simultaneously. So shift plus enter and these get executed, all right? And then you can just keep on executing them, but there's nothing, so it'll just keep on adding more and more shells. You can just remove these from here, okay? And if you ever do run into some kind of an error, like your notebook stops working properly or anything, uh, you can just restart the kernel and clear the output. It'll make sure that everything goes all right. And while you're doing this, make sure, like I told you in the last tutorial, make sure that your Jupyter notebook is on. Without this, you won't be able to, start this interface. So, all right, let's dive in now. All right, so first things first, we're going to be importing a few libraries. Sorry, NetworkX, NetworkX as NX. Okay, we're going to be needing matplotlibs for charting. So matplotlib.pyplot, by the way. Don't worry about this. We're not going to be touching up on matplotlib a lot, but it's only going to be used for charting. So just follow along with this one. Just memorize it. Okay. And again, matplotlib notebook. Notebook is the most updated command. Earlier it used to be here inline, but the most updated version is notebook. This is going to give you a much better visualization. Try it if you haven't already. And import seaborn as SNS. This is just for that fancy background that we had. Nothing special. We can do a couple more things with this library, but I'm not going to be touching over this in this course. And SNS.set again for the background. So this is basic stuff. You're going to be importing this whenever you're working on any project. All right. So once the importing is done, we can start writing code here. So basically, like I told you last time, we have edges and we have nodes. All right. So, but for having edges and nodes, we need to have graphs first. So first of all, we're going to create some graphs. So NX, that's your NetworkX dot. One second. Let me just load this. Like let this load. Okay, it's loaded. So once you see a number here, that means it's done. It's loaded. If there's a star here, that means that it's still executing. By the way, okay. So let's see. What do you want to name your graph? Let's call it G. All right. Keep it simple and short. nx.graph, and you can say that's a graph. Right? Simple. By the way, one more thing here. Suppose that you sometimes forget what function or what class you have to use where at some point of time, then IPython notebooks provide you with a really good feature here. Once you press tab, it'll show you all the suggestions, and you start writing and it'll still show you suggestions so that you can, decipher what you were really looking for. Okay, so you created your graph. Let's press Shift Enter for this, and you see it goes on to the next tab. However, I'm still going to be writing in this tab right now. Okay, so we have our graph, right? So what we want to do right now is we want to add some edges here, all right? We want to add some nodes and we want to add some edges. So there's this one really good thing about this library, that you don't have to add the nodes first to add the edges later on. That's not essential. You can do that, but it's not essential at all, right? So we can just say edges, add edge, sorry, and let's say that the edge is from node 0 to node 1, all right? So there, that's done. Now notice that it's not going to show you any output because you never really charted anything here. So to start charting, let's say plt.figure. This is basically telling the matplotlib library that we're going to work on a new figure right now, all right? So every time you want to, execute some piece of code and, visualize it, it'll keep doing it in the same figure unless you specify this. So once you specify this, it's going to tell matplotlib that, open up a new, what you would like to call it, new interface, and start charting in that, all right? Leave the last one alone. So that's it for this one, and let's start plt.figure. This opens up a new one, then nx.draw NetworkX, and we're going to be saying here, okay, I think that should be it. nx.draw NetworkX, cool. I think I missed something. Yeah, the graph. Okay, so you can see here 0, node 1, both of these nodes are connected to each other. So this is your first type of a graph, and we'd call it, this is basically, non-directional graph, or you could say just the normal kind of a graph, all right? So we're not doing directional graphs right now, so there is no arrow here, there is no significance that, we're seeing an arrow here, all right? Once we get to that, we'll get to that shortly. You'll see how it differs, but really this is it. Okay, so these are basic graphs. You can add more nodes here. Let's say you want to add edge again, from 1 to 2, and one more, add edge, and this is going from let's say 0 to 4. All right, so let's see this one. Okay, so there it is, right? That's your graph. You can fully connect it by connecting 2 and 4. You can connect anything else you want, but I just I just wanted to show you the basics here. And again, we can do this all with one command here. Let me show you how it's done. Um, g dot add edges from. Okay, so basically this is used whenever you want to specify multiple edges at once. So let's say we have 0 comma 1 as the first pair, right? And we have now, notice that you cannot separate all of these pairs by just adding commas here, so you're going to have to make tuples out of these, right? So let's do this, and then we have 1 comma 2, and then we have 0 comma 4, sorry, and let's create another one. Let's say 2 comma 0 again. Okay, uh yeah, and let's see this happen. All right, so you can see again that I commented this out, by the way, just so you know. So even without that, it'll work. Again, see, all of these nodes, as you said, one should be connected to two. There's a link 1 to 2. All right, so this is basically your non-directional graphs, where direction isn't important really. Okay, the second types of graphs we're going to be studying are, directional graphs. Right, so how this is going to work is, again, uh, we're going to be creating another graph. So let's call it G1 here. And this is a directional graph. So we're not going to be using the graph class here. So we're going to be using the digraph class. Di stands for directional, of course. Digraph. You can again see here the tab works again. And in the digraph, again, what you're going to specify here is, again, the nodes that are going to be connected. But the thing is that this time order matters here. So the order is from start node to the end node. All right. So let's see it happen let's see it happen. Let's chart it. It'll be a lot more easier, I promise you. Okay. So 1, 2, and then sorry, not here. This is just the graph object that we created. G1 dot edge add edge. Okay, it's not working for some reason. Okay, g1 dot add edge, and we're going to be adding 1 comma 2. Let's add another here. Let's see, 1 comma 3 again. This should be fine. Okay, and what we're going to do is we're going to chart this next. So make sure that you again pull up that command, sorry, plt.figure to tell matplotlib that it should be charted in the next figure and not the same one previously. So otherwise it would just clutter all over each other. So let's avoid that. And g1, sorry, nx dot draw NetworkX, and we're going to pass in g1 this time. All right, so notice that they are not essentially arrows here. So this is how NetworkX shows you that the direction is, these are directional graphs, and this node is from 1 to 3. This node is from 1 to, this edge is from 1 to 2, excuse me. So again, easy to figure it out, but, just make sure that you realize the difference between arrows and, these thick lines. They're the same things essentially, but this is just the way of representing it here in NetworkX, all right? The third type of graph we're going to see is a weighted graph. Again, I think I should just write it over here. Yeah, just to make sure that I don't forget anything. Yeah, weighted, and then I'll show you these things. All right. Okay, so weighted graphs, right? So what you're going to do is basically you're going to tell the graph that, okay, from this node 1 to 2, the weight is, let's suppose, 10, and from 2 to 0, the weight is supposedly 20. So the thing is that what happens in these kinds of problems is, suppose you have the traditional traveling salesman problem, or some kind of a problem where you want to find the cheapest route to get from 2 to 1, let's say. All right, and you know that there are two routes: 2 through 0 through 1, or 2 through 1 through 0 through 4. So notice that you don't know how much it is going to cost to travel this route or to travel this route. So really you have two alternatives here, and you can really solve these kinds of problems through networks by making sure that the weights are associated with these edges. So how we're going to do that is when we're creating the edges, let's see here. Let's keep it short and crisp for now. Yep, let's bring that back. Okay, done. Okay, so when we're creating the edge here, what we can specify as a third attribute is the weight, really. So I'm just gonna write weight is equal to, and again, for each one of them, we need a separate weight. So let's say this is 10, and this one is 20, this one is 100. Okay, so there are all kinds of weights here. So let's say this is actually 30. Okay, and one more here, 0, 1, 1, 2, and 0, 2 is not here, so let's just recreate that one. Make sure that the shape stays the same. Okay, 0, 2. Again, notice that the order does not matter here, so we can just carry on with our analysis. Let's make it 10. Let's make this 20. Okay, I think that's it. Now, one thing that you're going to notice is that the graph is going to remain the exact same. You're not going to be getting any kinds of weights here. That's because you never really plotted the weights. All right, so we need a way to tell matplotlib that we need the weights plotted over here. So first of all, we need to extract the weights, right? So how we're going to do this is that nx dot get edge attributes, all right, because these are edges basically. So the thing is that when these are edges, you need to get the edge attributes. Supposingly, if we describe nodes above separately, uh, by saying that g.node or something, then in that case we would be having to take out the weight from the nodes. But again, the nodes will never have weights because the edges are the pathways. So in this case, uh, this is the only choice here. But again, if you have some nodes and you have attributes associated with them, you can get the node attributes as well. So I'll be showing you that in a moment. Okay, what do we want here? We want the weight. Again, by the way, one more thing. If you ever want to check out the documentation, a quick view of the documentation, you don't know which attribute goes where, just type in a question mark here and then just execute this. And it'll show you the documentation right here. So first is graph and second is the name of the attribute, right? So let's do that. The graph is G and the name of the attribute is weight, right? So weight is what we need. Now we need to store it in a variable or else it'll just get lost, right? So this is the weight. Now we got the weight, and we need a way to tell matplotlib to plot the weights as well. So let's say nx dot draw edge labels, NetworkX edge labels. All right, so notice that I don't even have to remember the commands in this thing because this tab button is helping me out almost all of the time. So make sure that you don't focus on cramming stuff, but really understanding it. You need to know that this function exists in this library. Even if you forget it, even if you don't remember it, you can just do a quick Google search. You'll find your answer on Stack Overflow. So just understand how things work here, and it'll be fine. So edge labels, and what are the labels? Weight. And again, so yeah, this is what weight has really. It's a dictionary with all of the edges corresponding to their weights, right? So the thing is that when you do this, you need to specify the positions of the nodes as well, right? So how you're going to do this is you're going to say g.add node. So basically you're adding a node here, and we have to add 4 nodes. Notice that we have 0, 1, 2, 3, 4, right? Actually, no, we don't have a 3 here. So 0, 1, 2, 4. Why don't we have a 3 here? Okay, it's fine. So what I'm going to be doing is I'm going to be just pasting it here for 4 nodes, right? And we're going to write 0 here, and we're going to specify the position here. Okay, so the position is equal to you can say anything really, but let's say I'll call it 1 comma 1. Okay, and this is just where your nodes will appear in the graph, nothing special. pause equal to let's say 1 comma 2, then there's 2, pause is equal to any random place would work really, let's say 2 comma 4, and we don't have a 3, we have a 4 though. Pause is equal to 3 comma 4, probably works fine, I guess. So okay, we have all the positions, but again we have to pass it in this function. How? Let me show you. Documentation will tell you, sorry, I opened that one up by mistake. I need to open this one up. So the documentation tells you that you need G, pause, and basically edge labels is none, so you don't need it. So you need the graph and you need the pause variables. And edge labels, we're going to be passing the weights here because we don't want it to be none, of course. Why are we really doing all of this pause attribute? So yeah. Okay. By the way, this just executed because I made this a question mark, so it just made sure that I got my documentation and the rest of the code was already executing properly, so there was no issue here. Okay, let's move on. We have the pause, but we need a way to find pause out. We need a way to extract that into a dictionary, just like we have done with weight here. So pause is equal to, again, since this is a node attribute, what we're going to be doing is get node attributes, and we're going to be specifying the graph here. We're going to be telling it that we need the pause attribute, and we have the pause attribute now. And now this time we can pass in the attributes. Again, the order should be preserved, so the first one is G, then pause, then edge labels. All right, so the order here remains the same: G, pause, and edge labels we have it as weight. Okay, so that's done. Okay, so it should work now. Okay, the thing is that we haven't really told NetworkX that when it's drawing the graph, basically that these paws are the same as these paws, basically that the edges are these the same in this graph. So really, when you have paws, pass it into both of these and give the edge labels weight, and of course this time it should show. All right, so as you see, there's one node at 1 comma 2, there's one at 1 comma 1. So the positions have been identified and all of the nodes have been drawn on these positions. So this time the graph won't move every time, it'll be in the same position. And you can see the route from 2 to 4 can be through 2 0 and then 4, and it could be through 2 1 0 and 4. Of course this one is cheaper in this case, however it's not necessary that the shortest one will be cheaper in every case, but yeah, this is something that you can just do. um, One more thing here. Let's suppose that this was a graph in which you have friends and enemies, right? So how would you depict that? Of course, you'll have to use the color of the edge to depict something like that, right? And this could be their friendship score or their enemy score, like how intensely they are friends or enemies with each other. So to do something like that, I don't want to add in a lot of things in this video, but sure, this is just going to be the last thing. So um, okay, what we're going to do is we're going to associate with every edge another attribute called as relation. Okay, so relation is equal to, and let's just say most of them are friends, one is an enemy. Okay, or let's make this one also enemy. Okay, so we have 1 comma 2 and 0 comma 2 as enemies, the others are all friends. Okay, so how do we depict this? How do we tell matplotlib that we want two different colors here? So what we're really going to do is we're going to say that, okay, when it's drawing the graph, it should, well, if you are not sure, like I'm not right now, just make sure that you check out the documentation first, right? Okay, here it is, node color. Okay, this is node color, but we really need edge colors. So edge color, all right? And it should be color string or array of floats. Okay, so what we're going to be doing here is we're going to give it an array, so edge color, and we're going to be giving it an array, but this array is going to be referencing its data from a dictionary. So if it's an enemy, let's say we'll make it red. If it's a friend, we'll make it blue. So what we're going to do is we're going to write a small function, would say, no, or we won't have to write a function, but what we can do is basically let's just create a dictionary first here. So dictionary is equal to, well, when it's an enemy, make it red, and when it's a friend, then make it blue. So again, just so you know, if people don't know about dictionaries here, these are key value pairs. This is the key, this is the value. If an enemy occurs here, it'll give you red. If a friend occurs here, it'll give you blue. All right. So that's how we're gonna get the labels out of this. So what we're gonna say here is basically give the attribute dic x for x in what? Well, for x in relation, but we do not have relation yet, so let's define relation. If you don't get this, just hang on with me. I'll explain in one minute. nx.get node attributes, sorry, edge attributes, because relation is again associated with edges, and we're gonna get these for graph, and we're gonna get it for your relation attribute. Okay, so we have the relation now, we got it, and this time what we have to do is we're gonna have to say, okay, the x for x in relation. Just let me make sure that this is running, and once that happens, okay, this isn't running. Key error 0, 1. The x for x in relation once again. Oh, sorry, my bad. Notice that when I print relation here, it'll be something of this sort. So basically the edge and your relation after that. So what you really need is relation.values that will give you these values: enemy, friend, again, uh, in the reverse order, of course. So now let's try it. Okay, so you see 0 and 1 are friends, 0 and 4 are friends, the others 1 and 2 and 0 and 2, as stated earlier, are enemies. So this is how you can depict something like that. You can also add legend here. I'm not going to be covering that since this is already a very long video. Make sure you watch this twice or thrice, because these are the core concepts. If you do not get this, there's a lot more to come. You won't be able to understand it, but trust me, this is easy. And one thing that I wanted to explain was this thing. So in Python, let's suppose that when you have, let's say, a variable y is equal to, range, or let's not go over range. Let's say a variable y, which is a list, 1, 2, 3, 4, and 6, all right? And you wanna create another list, and you wanna print it like this. Let's say yy, for yy is again a variable. This is again the short form for a loop. I can again write this in a loop form, and I can again write this in this form. This is the shorthand form. Okay, so let's just go for the loop first for yy in y. Okay, and what we're going to be doing is we're going to print y. Right? So here we see we have all of these values, right? So what we're going to be doing is writing the short form now. So yy for y, yy in y. So basically we read like this: for yy in y. Okay, just leave this part out for now. For yy in y. So basically for every yy in y. So for 1, 2, 3, 4, 6, because all of these are a part of y, right? So for yy and y, give me back this thing. Okay, so give me back yy, and this time again you'll see the result will be the same, only in list form, because of these list brackets. Okay, so exactly what I did here, let me just make it easier for you to understand. When I did relation.values, you'll get all of these values: friend, enemy, all of these. So let me just run it for you, and you see dict values: friend, enemy. Okay, so it gives you these values in that order. Again, this is your set, just like yy was. So this was your yy, right? And your y was basically iterating over all of these values, right? So when you say list, okay, yy for, sorry, this was y, my bad, yy for yy in y. Now it's basically looking for each of these values in y, and it's calling them yy. Again, a for loop basically runs and it gives you this thing, right? But this time, notice that we don't need yy here, because otherwise it'll just print friend enemy like it did. But we don't need this here. This time we need something that's coming out of this dictionary, right? So we need to make sure that basically we put the dictionary to use here. So what I'll do is I'll say that dictionary, and for dictionary, I'll pass in yy inside, right? So this will be your key. So if enemy comes into the dictionary, it'll return red. If friend comes into the dictionary, it'll return blue. So basically, this is all it is. And see, blue, red. So again, I'm going to be putting all of this code on GitHub. The video link will be in the the GitHub link will be in the comments, and make sure you let me know how you found this video, and I'll be doing a couple of more videos soon enough. Uh, I have a lot more of networks to explain, multi-networks especially. So we'll be going over that in the next video. So thank you, and I'll see you in the next.